All right, I'm here to talk about Lab 8. Um, so this first part, over this part of the circuit over here is our part A, which is a voltage-driven current source. Basically, we feed in 15 volts into the circuit, and this potentiometer is there to manipulate how many voltages are being driven into this subcircuit. The purpose of this subcircuit is to convert a constant DC input into a constant current source that flows through the rest of the circuit. Here, on this computer, we see the relationship between the voltage coming in as well as the output current. As you can tell from the slope, it's to the slope. It is almost identical, or it's pretty similar to the load resistance that we are using for this circuit. Here it says it's around 972 ohms, while the resistor we used was a 1 kilo ohm plus or minus 5%. It's a linear relationship because of Ohm's law. All right, so on this side of our circuit is the subcircuit for part B, is the Schmidt trigger. And what a Schmidt trigger does is it outputs a maximum or minimum voltage depending on whether the input voltage has crossed both threshold voltages that the designer decides. In this instance, our reference voltages were 3 and 7 volts. So the usefulness of this circuit is that it determines whether a voltage is above or below like the reference voltages that you decide. So all these sub-circuits, including the current mirror in the middle, build what's known as the VCO. It's for part C. And so here's our part A, here's our part B, and then in the middle we have the current mirror. When we look at the output of the part of the VCO, we see that as the input voltage increases from 3 to 7, and because what we have is actually an inverting Schmidt trigger, what should be a low output is in fact a high output, and these outputs are related to the rail voltage, the positive negative rail voltages, and when we're going from 7 volts to 3 volts, it's a low input instead of a low output instead of a high output.